my name is Jamie Bunker, and I'm a 4th grade teacher at Manchester Elementary School. In 4th grade, students are learning alternatives to the traditional algorithm for dividing. And one strategy for that is called the partial quotient strategy. Along with strategies for dividing, students really are working on building an understanding of what division means. And so one of the ways that we do that is to provide lots of manipulatives and concrete models. These are called base 10 blocks. And this base 10 block stands for 100. This is a model of a 10, and this is a model of a 1. And while students use these at their seats, another way for me to model during class is to use a base 10 model on the board. So these would stand for the 10, and these small squares would represent that 1. We're going to use this model to help us build an understanding of what 74 divided by 3 actually means and what it looks like when we're dividing. So one way to think about this problem would be 74 blocks or 74 things divided into 3 groups. So here I have my 74. I have 7 10s and 4 1s divided by 3. So to represent that 3, those 3 groups, I'm going to draw 3 groups that we'll divide into. And then I'm going to rewrite the problem to help keep track of my thinking in a better way. So I have 74 divided by 3. So when we're thinking about this problem, I would want students to first think about the largest place value, which in this case is the 7 10s. And we have these 3 groups. So we could, while we can't divide all 7 10s equally among these 3 groups, we can divide at least 2 10s evenly into each of those groups. And this model helps students to see what's happening as we're dividing. So to keep track of what we've done so far, I'm going to record what I've done with my model. We have 2 10s in each of our 3 groups, which is the same as 20. The outside is where we keep track of how much is in each group. And then on the inside, 74 was the total that we began with. So now we want to keep track of how much of that total we have left to still divide. 20, 40, 60. We've divided 60 of our total into those 3 equal groups. So I want to subtract 74 minus 60. We have 14 left. And you can see that in the model. We're still dividing. We have 1 10 and 4 1s remaining. Now, with 3 even or 3 groups, we can't divide 1 10 equally among those 3 groups. So we need to think about this 1 10 as 10 1s. Right? So now, instead of 1 10 and 4 1s, I'm thinking of this difference as 14 1s. This is the part during division that we really want students to use multiplication to help them think about solving division. So we have 3 groups, and we're trying to divide 14. So one way to think about that would be 14 divided by 3 equals something. Or something times 3 is close to 14. In this case, I know that 4 times 3 is 12, which is close to 14. So we can divide 4 1s into each group. Again, using the model helps students to understand what all of these numbers mean as we're dividing, and it scaffolds their understanding of what division really is. So again, we want to record what we've done in our model. We've put 4 1s in each group, and 4 times 3 is 12, which means we still have 2 left to divide. And you can again see that in the picture. We have 2 1s remaining. Because there are only 3 groups, we can't divide 2 evenly among those 3 groups. So this 2 is now our remainder. When our difference is less than our divisor, we know that it's a remainder. We can no longer divide evenly among those 3 groups. So to find our final quotient, we want to add the partial quotients. 20 plus 4 is 24. And then we can record that. 74 divided by 3 is 24, with a remainder of 2. Students can then use their model to double check their thinking and make sure that their answer makes sense. So in each group, they have 2 10s and 4 1s, which shows 24 in each group. So 74 things divided into 3 groups means there's 24 in each group with 2 remaining. So using the partial quotient strategy helps students understand the meaning of division.